Hi everyone, and welcome to my presentation on the fascinating world of analog transmission for digital data. Today, we'll delve into 4 key modulation techniques: amplitude shift keying, ASK, frequency shift keying, FSK, phase shift keying, PSK, and quadrature amplitude modulation, QAM. Imagine this: you have a message, but it's in the form of zeros and ones, the language of computers. How do you send it across long distances, through noisy channels, and into someone else's computer? That's where analog transmission comes in. Now we go to meaning of analog transmission is to send the digital data over an analog media. It needs to be converted into analog signal. We also know that band pass, the filters are used to filter and pass frequencies of interest. A band pass is a band of frequencies which can pass the filter. Low pass, a filter that passes low frequency signals. When digital data is converted into a band pass analog signal, it is called digital to analog conversion. When low pass analog signal is converted into band pass analog signal, it is called analog to analog conversion. Next, digital analog modulation is a process of changing one of the characteristic of an analog signal based on the information in a digital signal. It have 3 characteristics: amplitude, frequency, and phase. Digital data, binary 0 and 1. We also know that there are 3 types of digital analog modulation: amplitude shift keying, ASK, frequency shift keying, FSK, phase shift keying, PSK, and quadrature amplitude modulation, QAM, is a combination of ASK and PSK. Amplitude shift keying, ASK, is the simplest technique in this conversion technique. The amplitude of analog carrier signal is modified to reflect binary data. When binary data represents digit 1, the amplitude is held, otherwise it is set to 0. Both frequency and phase remain same as in the original carrier signal. This on-off amplitude modulation is widely used in applications like RFID and remote control systems. Frequency shift keying, FSK, the frequency of the analog carrier signal is modified to reflect binary data. This technique uses 2 frequencies, F1 and F2. For example, F1 is chosen to represent binary digit 1 and the other one is used to represent binary digit 0. Both amplitude and phase of the carrier wave are kept intact. FSK is commonly found in applications like data modems, wireless communication, and even in some types of fax machines. Phase shift keying, PSK, the phase of the original carrier signal is altered to reflect the binary data. When a new binary symbol is encountered, the phase of the signal is altered. Amplitude and frequency of the original carrier signal is kept intact. Applications include satellite communication and wireless LANs. Quadrature amplitude modulation, QAM, a combination of ASK and PSK so that a maximum contrast between each signal unit, bit, dibit, tribit, and so on, is achieved. The phase and amplitude of the carrier are varied. The frequency constant remains. I hope this presentation sparked your curiosity about analog transmission. Let's keep exploring the wonders of technology together. Thank you.